go. A person with heart problems is asked by his doctor to take a systolic blood pressure reading every day for a month, 31 days. If there is good evidence that his average blood pressure exceeds 140, then he will be prescribed a new medication. Okay. This might be something that your parents have to do. I don't know. Assume
jogging heart rate or just like normal?
This is normal. This is actually a higher heart rate. That's why he's probably going to be on high blood pressure medication. All right. So it says assume that the average of all these readings is 144.5. The patient explains they shouldn't use the new medication because it was simply luck. That explains why these readings averaged over 140. Is there strong evidence for the doctor to go ahead and prescribe a new medication? Follow the entire procedure to conduct this survey. All right. So this is on that page 109. So our null hypothesis and our alternative are the first things we're going to come up with. Okay? So he's saying that it's equal to 140. The machine is saying that is greater than 140. So we'll say that mu is the average blood pressure. Okay? Pretty simple so far. That's just the Greek letter mu if you don't know it. All right. We good so far? Okay. Happy to see how this is going. All right. So 31 days is how many samples this person's going to have. Okay, so n is greater than 30, which is good. Random sample. Nope. This person just collected data. Hello.
Nice to see you.
All right. All right, so sample's big enough, but it's not random. Random, that says nope. Okay, we're on page 109 for those who just got here. Let's see. I guess we should probably try and find the standard error. So the standard error, they told us the standard deviation was, we don't have one. Oh, I'm going to tell you that the standard deviation, we'll add it, do it in your best TypeScript, best way. Standard deviation is 25. Okay. So for whatever reason, we skipped it. Okay, so the standard error is going to be 25 over the square root of the sample size. So this is going to come to, yay, look what already happened. Let's just open up a new window. We'll go back to that. All right. Can't get this to go away.
Okay. Special access.
All right.
Don't spell anyone's name wrong.
All right. Come on, board. Catch up with me. We got the death spin.
What if they spell their own name wrong?
Then that sucks for them.
Yeah.
Okay. Why are we frozen? We're frozen. Let it go. Let it go. All right. So from there, so we have our null. Mu is 140. Our alternative. It's greater than 140. And I told you to add the standard deviation of 25. So we got 25 over root 31. 4.5, I'll go with that. Yep. Yes. All right. So normal curve is going to look like this then. Woo! And so we know that 140 should be here. And then we count right. 144.5. 149. 153. 135.5. 131. And 126.5. All right, so they're saying that this person had a blood reading of 144.5. And then we're shading this way. Okay, so, yay. Let's see. Let's go ahead and figure out the p-value now. How do we find the p-value in this information? Go to the calculator, right. Go into Desmos. Desmos. Get rid of this. So we're saying 140. We said standard error was 4.5. And then we're going to figure out the area. We're going 144.5 here, or greater. So we have a 15.9% or 0.159. So our p-value is 0.159. Okay, so since our p-value is greater than 0.05, fail to reject, FTR, the null. Okay? We do not find strong evidence. Okay? All right. So the disclaimers on this one, you guys all understand. I mean, this is something that doctors often do. You go in and get a physical. You might have high blood pressure. They might have you get one of those little battery blood pressure cuffs. They want you to check your blood pressure throughout the next 31 days. This is not a random sample. So basically the patient is right saying this, but dude, they are a medical doctor, so they might know what they're talking about. But you also know that with anything that has to do with medicine, it becomes your body. You can make the choice to say, I don't want to do this or that. Okay? So I'm not saying medicines are bad. I'm just saying some of you might make choices not to take certain medicines. There are definitely medicines in my life that they've suggested I be on, and I suggest I don't want to be on. But I don't have this kind of data. I just am stubborn. All right. Backside. You with me? Soda companies. Oh, I like soda. Soda companies often perform taste tests on new products to see if they should be released as a new product. The new flavor is being tested. The company determines that if the average score on a scale from 1 to 10 is shown to be higher than 8.5, then they will release a new product. Hey friends, what is the 1 through 10 scale? What is that called? was so first semester. You guys remember the scales? That's it, the Likert scale. Good deal. So this is a Likert scale. So they're saying, and they say 20 people are hired as taste testers. Assume the average score is 8.78. Is there strong evidence that this product has reached the proper threshold? Follow the entire 6 steps. All right. Friends. 20 people are hired as taste testers. Is that a random sample? Huh? This is on page 110. Does it say it's random? Basically, they hired 20 people to take this. It's not a random sample, and our sample is not, it's not above a certain amount. So technically, which test should we do? Not a normal distribution, but almost like 8 letters back from Z.
Wait, I know. No. Wait,
T.
Oh, T distribution.
T distribution. All right. So it's a T distribution. Okay, so let's think about this. So we have our null and our alternative. Our null, mu is equal to 8.5. Mu is greater than 8.5. Our sample is 20. Okay, so this points to a T distribution right away. Okay, so let's go and figure this out. Okay, so mu is the average taste on this Likert scale. Okay, does everyone understand why we're using a T distribution? We have less than 30. T distribution is where we should go to. Things that should stick out to you is it was not a random sample. You paid people to go in and take this. This kind of goes into the whole thing. You're being watched. So you remember when we talked about statistics, there was that Hawthorne effect, I believe they called it. Hawthorne effect. If you're being watched, yeah. Look at us knowing all those statistics. We are amazing. Yeah, okay, cool. Had to learn somewhere. All right, so let's change this to a T distribution. All right, so I need to go functions, come down. Look at the T distribution. Hey, when it says enter the degrees of freedom, if we have a sample of 20, what's my degrees of freedom? Close.
15.
More.
13.5.
19. It's one less. One less than our sample. All right, so there's your T distribution. Looks very much like a normal distribution. And I guess we should say that we could find a standard error, which would be fine on this case. But let's see, how would I make that work with a T distribution? Yeah. All right. So let's go back. I think we can incorporate a standard error into this. Okay, so they said, oh, I didn't give you this in this problem. I'm sorry. My original has it. This one doesn't. I have a standard deviation of 1.1. Okay, you'll have to add that. I'm sorry we docked it out. I don't know why. So I'm going to go 1.1 divided by the square root of 20. So it comes out to 0.25. All right, so there's our standard error. All right, so let's go back and take a look at this. I'm sorry.
Okay.
Good? All right, so we're going to use the standard error. Now, our T distribution goes between 0, from -4 to +4, with 0 in the middle. Okay, so we can't really find our average of 8.5, but we can indeed look at our standard error. Hello. We can look at our standard error and incorporate in this. So our standard error being 0.25, we can do that. So if we go 0.25 here, 0.25 here, we come up with roughly 40% or 0.4, 0.40, 0.402, something like that. All right. So our p-value is 0.40. Okay, is that bigger than 0.05? Is 0.4 bigger than 0.05? Is 40 cents bigger than a nickel? Yes. So since that happens, we fail to reject the null. We do not find strong evidence that the average taste score of this new soda is greater than 8.78. Okay? So, yeah, we're failing to reject the null. Basically, they're saying, hey, we're exactly equal to 8.5. You said you wanted to be greater than 8.5, so soda company, don't release that new flavor. It's going to fail, even though we didn't have a random sample, even though this and this and this, all these different things took place. So that was a pretty good problem. I like that. All right, so I have a question. Any of you have questions about what we had done here? Is there any question about why we used the t-distribution versus that? The other thing, with the t-distribution, you can use the standard error that they put you, meaning basically what this means is that 0 at the bottom of my screen is theoretically 8.5, and we could go from there. Okay? Are you doing a Kahoot that's not here?
No, it's not.
Are you one of those kids that you signed into your friend's Kahoot in your class with some weird class?
For like 2 days, and I need to study for my test and I finished it.
What?
Yeah, and it says the Kahoot's not open anymore.
What?
So now I don't know what to do.
Oh no, that's horrible.
It's fine. Yeah,
All
it's
right.
horrible.
Hey, how do you feel on a Monday?
My code is still wrong.